If we consider two vectors, there are three ways that we can display these specimens. No, it is not that kind of three-way, but still interesting. One case is when the vectors point in the same direction. Now for the second case, we have it when the vectors have opposite directions. Lastly, the vectors are perpendicular. Let's go over them one by one. When the vectors point in the same direction, the dot product always has a positive value. For example, consider the same vectors v and w that we have been working with. If we plot them, we can see that they point in the same direction, and applying the dot product formula to their coordinates gives us back a dot product of 7. Conversely, if the vectors point in opposite directions, the dot product will have a negative value. Say that for v we have the same vector as before, but now let's define the vector w in such a way that it points in the opposite direction of v. For example, say that w has coordinates -1 and -2. If we calculate the dot product between these vectors, we will end up with a value of -8. The last case to cover is when the vectors are perpendicular, meaning that the angle formed by these fellows is 90 degrees. Again, v has the same coordinates as before, 2, 3. Now for w, we will select the values of -3 and 2. If we are after a scalar that represents how much a vector points in the direction of another, visually we can see that it makes sense that in this particular case, this same value must be 0. Let's calculate the dot product just to ensure this conclusion. As expected, we get a value of 0. To finalize the video, let's create a table with the different values for the dot product. If the dot product is positive, it means that the vectors have the same orientation. For cases where the dot product is negative, we have vectors pointing in opposite directions. Lastly, if the dot product comes out as 0, this means that the vectors are perpendicular. In the next video, we will go over a use case for the dot product where we will build a very simple recommendation system. Also, if linear algebra for machine learning is of your interest, consider checking Volume 1 from the series of books that I am working on. A conversational-style mathematics book full of visualizations and real-life examples. Links are in the description. Thanks for watching.